Okay, this unit's called exponential functions, starting some new topics here. Actually, it's a mix of some new topics and some old topics, reviewing some really important stuff. It's a collection of different topics and skills that revolve around exponents. So part one, we're going to talk about simplifying exponential expressions, which a lot of it should sound pretty familiar to you, and maybe even some of the starter stuff is going to be so basic, you'll have your eyes rolling in the back of your head, but there's some really important details I want to get to too. So I'm going to kind of take us right back to the basis of exponents and then build up from there. All right, so first, obviously, everyone should know that the bottom number in our exponential expression is called the base, and the top number is called the exponent, and altogether, that's called a power. So when we say a power, we really mean the two parts combined. All right, now, first thing we got to talk about, the number one thing that people mess up and make mistakes all the time, they don't put their brackets and all these kind of little issues is my answer going to be positive or negative? And this is something we need to completely understand, especially at this grade level by this point, if we're looking to move on. So obviously everyone knows how exponents work at this point. So let's start with, 2 times 2. Obviously 2 squared is 2 times 2. The result is 4. Obviously, hang on, let me delete that there real quick and fix it, change the color. All right, 4 to the power of 3, 2 times 2 times 2 is 8, and yada, 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 right? So you start with a positive base, you end with a positive result. Nothing changes here, right? Why would this change to negative, right? Okay, now, same thing or similar thing occurs when we have a negative in front with no brackets. So the key here we're looking at, there are no brackets around the base, okay? So in this case, if there are no brackets on the base, we treat the negative as something that's not repeated. So if I have a negative out front, basically we're saying that there's only one negative, and my answer is going to be automatically negative. So I have one negative, and then 2 times 2 is 4, so it's negative 4. Or one negative, and 2 times 2 times 2 is 8, so negative 8. So in this case, we start with a negative on our base, and we ended with a negative. So long story short, let's just kind of summarize this, right? Obviously, this is conclusion for starting positive, ending positive. I'm not even going to write anything there because it's pretty obvious. If there are no brackets, so the conclusion we have to know, and the thing we really need to know about here is if there are no brackets, right, around the negative. Okay. Around, I'm going to pause and write the rest of this. Okay, there we go. So if there's no brackets around the negative, the result stays negative. So it starts negative, it ends negative, okay? We don't care if the exponent's even, odd, anything like that. However, this is important when we're substituting into things or when we are given an expression that involves brackets. Let's look down here at when we do have brackets, so with brackets on the base. So in this case, the negative is repeated. We repeat everything that's within the bracket. So obviously we can tell just by looking at the exponent how many negatives we're going to have. In this case, right, I'm going to have 2 negatives, 3 negatives, 4 negatives, right, because we're repeating the negative and the number inside. So it's going to switch back and forth. We're going to get a positive result, like positive 4, negative 8, positive 16, negative 32, positive 64, and so on and so forth, because the number of negatives is increasing by 1 each time. So all of these started with a negative value on the base, right? So I'm just going to write the negatives in here. But only some of them end up with negative exponents, or sorry, negative results. We'll talk about negative exponents coming up a little bit later. So long story short, everything that has an even exponent is going to end up with a positive result. And everything with an odd exponent is going to end up with a negative result. All right, so I'm just going to write that in the conclusion here. Okay, so there we go. So with brackets around the negative, if you have an even exponent on the outside of the bracket, you have a positive result. If you have an odd exponent on the outside of the bracket, you get a negative result. So usually when we do this unit, we do the first little bit without calculators, making sure we have a good understanding of this. So like a classic test question would be one, here's a nice basic one, -1 to the power of 100. Right? What is that without a calculator? It's pretty easy. I have 100 negatives, right, repeating, so that's positive, and 100 ones. Well, 1 times 1 times 1 is 1. So there you go, it's just positive 1. Or another basic, just to make sure you understand the concept. In this case, I'd have -1 because I have 99 negatives, an odd amount. All right, let's move down and look at the product rule, the quotient rule, and the power rule, and summarize those and make sure you remember those and understand not just how to use them, but why they work and why they are what they are, because really understanding them helps you tackle the more difficult questions. Those of you that skim through and skip all that generally get stuck when we try to explain the more difficult questions. So try to, make it through it. Okay, first rule we need to know that we definitely cover in grade 9 is the product rule. Also think about it as multiplying, right? So how does this work? When you have the same base, so we can just use x here to represent any base. So we have the same base. When we are multiplying, we can add the exponents, right? So x to the m times x to the n, I can add the two exponents. So if I do one like this, 2 to the power 2 times 2 to the power 3, most people when I show it to them, they go, okay, yeah, it's 2 to the power 5, and they move on. And yeah, when we're doing our homework, we can do it that simply. But what we really need to do is understand why it works first, so that if you can really understand the 3 big rules here and understand how they work, you can solve anything. If you just skim through and all you know is this, people start running into problems and it gets more difficult to explain. So let's just break this down a little further. All right, so 2 squared, right? Obviously that means 2 times 2. And we are multiplying it, so I'm just going to put another dot and use some different colors here, by 2 to the power 3. 2 times 2 times 2. So obviously now that we write it out this way, and we really shouldn't have 2 equal signs on one line, but I only got so much room here, so we'll just squish it in there. Right, we have all multiplication. Multiply, 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 right? And we have 5 2's. So if we want to write that as a power expression, it would just be 2 to the power of 5, right? Let's break down this one too. And again, this first one's pretty easy to understand when you break it down. It's not a lot of complexities to it, but really getting an idea of that you can break it down this way, especially when you get to the challenging ones. Stop if you're having trouble or not getting the right answer and break it down like this again and think your way through it this way. All right, so let's look at this one here. So we have 3x squared, right? So 3 times 2x's. If we expand that, that's what that would look like. 3 times 2x's times, so I'm just going to put another dot there for times, a 4 and 3x's. Right, so if we expand this out fully, this is how we would write it. 3 times x times x times 4 times x times x times x. Well, we can rearrange this. Multiplication is commutative or commutative, depending on how you say it, which means you can change the order. What do I mean by that? Like 2 times 3 is the same as 3 times 2. So the order, you can change it any way you want. So I can take this expression and change it to 3 times 4 times x times x times x times x times x, right? And group them together and say, well, obviously 3 times 4 is 12. And I have 5 x's, so it's x to the power of 5 to simplify it, right? Now, again, our goal is 99% of the questions we do, we don't want to write all those steps. We want to go right from here to there, okay? But when you get stuck, when you start questioning the shortcut, because these exponent rules are really just shortcuts, stop and break it down the long way and think about what you really have in the question, and all of a sudden the answer comes a lot easier with these. They're pretty easy questions when you break them down, but obviously when I say break them down, or expanding them is what I really mean to say instead of breaking down. When you expand them, it takes a lot longer to expand it, but you generally are always going to get the answer right. So if you're stuck on one, do that. Now, these 4 here are pretty easy. Let's just plow through them really quick without expanding. So obviously, I'm just going to add the exponents. It's 7 plus 13. Even when you're doing your homework, you can skip that step and just go to 20, right? 5 to the power of 20. All right, we got a to the 7 times, if we don't see something up there, it's really a to the 1. So this is a to the 7 plus 1 in the exponents, so we have 8 a's, right? And again, why is that? Think about it. There's 7 a's here multiplying each other, 1, 2, 3, 4, 5, 6, 7, times 1 more a. Well, altogether, there's 8 of them, right? All right. Moving on. All right, so this next one, let's just do this in one step. Multiply the numbers out front. 2 times 4 is 8. Add the exponents on the y's. 8 times y to the power of 5. Sorry, I'm stumbling over my words. I'm trying to go quick because these videos are too long, but it's making me stumble more. All right, last one here. Negative 3 times 2 is negative 6. Now, add the exponents on the a's. There's 2 here, an invisible 1 there, so there's 3 a's. We got 4 b's times 6 more b's. It's b to the, I was going to write 20. I don't know what I'm thinking. B to the 10. So again, don't forget what people start doing, and I almost fell into it somehow. Right? They see this and they go, oh, I'm going to multiply them and go b to the 24. And then, no, you're not multiplying the exponents, right? You're multiplying the bases. And what does an exponent mean? This is the real thing. What is an exponent? This is the question you have to ask yourself. What is an exponent, right? What do they mean? Okay, an exponent, what does it mean? It means repeated multiplication. Exponents are just repeated multiplication, okay? I don't know why I'm putting in quotes. That's making it seem like it's not that. I'm misusing quotes here. Let's get rid of that. Those don't make sense. That's like me saying it's not what it means. But that's the key, okay? Repeated multiplication. It already is multiplying. So when we say we have b to the 4 times b to the 6, it means we have 4 b's that are multiplying. We have 6 b's that are multiplying. All together, how many things are multiplying? There are 10 b's, right? Okay, that are multiplying. That's the exponent, is just to group together that multiplication. It's used for grouping it, right? Just to make it easier to write. Okay? All right, so let's move on to the quotient rule, and this is one that's really important to zero in on. Again, it's simple, but really getting a deeper understanding of it, making sure you understand, okay? Okay, so the quotient rule. Also, what is a quotient? That's what you get from dividing, right? So when we divide powers that have the same base, we can subtract the exponents. So this is the inverse of the product rule, right? So x to the m divided by x to the n. Notice how the base stays the same. Now, this is one of those ones everyone seems to at one point or another fall into the trap. So like, for example, we'll even look at this one, 2 to the power of 5 divided by 2 to the power of 3. The answer, the shortcut answer would be 2 to the power of 2. Right? I subtract the exponents. But you would be, well, maybe not surprised, but how often the answer that I see is this. A lot of people go 1 to the power of 2, right? And I go, no, it's 2 to the power of 2, right? We try to explain why. And the general hang up where people are confused is they go, but I'm dividing the 2's here, right? Don't I divide the 2's and go 2 divided by 2 is 1, right? That's where the argument keeps going. So let's break down why it's not 1. The answer is it's not 2 divided by 2, right? The exponent represents repeated multiplication. So what we actually have on top are 5 2's. 1, 2, 3, 4. 5 2's divided by 3 2's. So when we're dividing, it's not 2 divided by 2, right? It's 5 2's divided by 3 2's. So what this really means, and this would be the expanded form, 2 divided by 2 is 1. Yes, you're right. A single 2 divided by a single 2 is 1. And another 2 divided by 2 is 1. And another 2 divided by 2 is 1. So what's left, though, is 2 2's, right? So what we have left, here we go, 2 times 2, which is 2 squared. This is the one, and again, I get it if you're just like, yeah, I get it, move on. This is the one everyone seems to at one point or another, and you'll see when we get in the more complex ones. On the first starter ones, everyone's like, never makes a mistake. And then we get in the more complex ones, and it's amazing how many times everyone seems to fall in this trap, and even like they, smack their own head and say, oh man, how did I fall into that? It happens. So keep in mind the idea of, remember, expanding. Expanding this helps you understand it, especially when you're stuck and getting to more complex ones, okay? Okay, so let's look at the next one. Again, this next one, in fact, I'm just going to erase all of this here so I have a little more room to do the next one here. Let's expand it. No, you don't have to expand every question this way. I don't expect you to do 2 to the power of 5 divided by 2 to the 3 in steps. I expect you to just go, it's 2 to the power of 2 and move on. It's the understanding when you get to more difficult ones, that's when you want to expand. And you'll see those of you that continue in university level math and start doing things, expanding something out can really help you understand all the components that are there as part of the question, okay? So let's look at one more here. So again, I'm just gonna write this with the fraction line. If you want to get technical, it's called a solidus. And we got a 12 on top. Hang on, let me just erase that, fix that. Oh, my line looks terrible. Okay, 12 and 5 x's. X times x times x. I'm not going to put the dot operator in between there, the multiplication operator. I'm just going to write them side by side like that. And 3 times x times x times x. So this is what's really happening. Now, the 12 and the 3 I can divide like normal. We're not playing with exponents. They each have an exponent of 1 here. They don't even have the same base. We can't use the quotient rule for them. That's just 12 divided by 3, right? 12 divided by 3 is 4. But what happens is then most people go back to this question and go, well, why didn't you divide the 2's here and make it 1 squared? Like we just said, in this case, they have the same base and there are multiple 2's and multiple 3's, right? It's not just 1, 2 divided by 1, 2. This is 1, 12 divided by 1, 3. 12 divided by 3 is just 4. We don't need to bring exponent laws into it. Here we want the exponent laws to simplify the x's, right? X divided by x, x divided by x, x divided by x. Remember, no matter what number x is on the top, it's the same number on the bottom. It's the same variable x. We can't use the same variable to represent two different numbers. So what's left there are 2 x's. So you have 4 times x, which would just be 4x squared. Now again, what we really want you to be able to do 99% of the time is just go from here over to there. Okay, you don't have to show all of this work here. Okay, we can do it in one step. 12 divided by 3 is 4. Subtract the exponents on the x's, okay? But when you get stuck, I know I'm broken record here, expand it out to help yourself, okay? All right, so let's just do these ones really quick here. Let's not mess around too much. All right, so the first one here, x to the 6 divided by x to the 2. You're just going to subtract them, it's x to the 4. What about this one? I really want to talk about briefly, but it's important. A to the 5 divided by a to the 5. Well, if I subtract the exponents, right, 5 minus 5, it's a to the 0. Right? Well, what's a to the 0? What's anything to the power of 0? It's 1. It's not 0. Why is that? Think about it. Let's do it this way. Let's break it down the long way. A times a times a times a times a divided by a times a times a times a. That's what it really means in expanded form, right? Well, every time I divide an a by an a, I get a 1, right? So what's left? It's 1 times 1 times 1 times 1 times 1 on top. The same thing on the bottom. What do you get? 1 divided by 1, which is 1. So this is why anything to the power of 0 is 1 and not 0. It's the same term on top as it is on the bottom, right? The same terms. Anything divided by the exact same thing is 1. So it's not 0. So that's one to keep in mind. All right, 12 divided by 2 is 6. Don't forget about invisible exponent, right? We just don't write it in. Y to the 4 divided by y to the 1 is 4 y's, cancel out 1. You're left with 3 y's. Same with this guy. Negative 10 divided by 2. They're not the same base. We're just dividing a regular negative 10 divided by 2, which is negative 5. Subtract the exponents on the a's, which is 3. Subtract the exponents on the b's, which is 1. But if your final answer has a 1 as the exponent, you are expected to not write that in. So there's your final answer. Okay? That would be fully simplified. All right, let's move on to the last rule for today, the quotient law, quotient rule. All right, I misspoke. It's not the quotient rule. We just covered that. I meant the power rule. All right, so this is the final one of the big three, and then we'll just review the power of 0 really quick again and just comment on some important stuff with that. So the power rule. This is where things really start going. So people start doing stuff like this, right? Now, first, let's just tell you what the rule is. When you have a base that has 2 exponents on it, right? Here we go. The base stays the same. That is the key. This is where things go wrong. People start changing the base. Notice how none of these questions we've changed the base. The base stays the same, right? We're not messing with the base. So here's a good tip. What do we got here? Oops, the same. Okay, the tip is if you're working on the exponent, you should never be changing the base. Okay, they shouldn't change at the same time. So if you don't believe me, let's just flip back and look at the other guys real quick. Look, the base here stayed 5, right? Let me just grab a highlighter here, right? Base stayed 5. Base stayed A. The base stayed Y. The 8 is not the base that the exponents are on. The base stayed A. The base stayed B. The base stayed 2, right? The base didn't change. Same with the quotient rule, right? What was the base? X and X. The base stayed X, right? And so on and so forth. If you're changing the exponent, you are not changing the base. So what happens is all we do is multiply the exponents with the power rule. That's it. Power of a power. Now, what people do wrong here, the right short answer for this one should just be is 2 to the 6, the end. You multiply exponents, you don't change the exponent. But what people do is this. I always see them go, well, it's 2 to the power of 3, right? And they'll go, okay, 2 to the power of 3, 2 times 2 times 2 is 8. And then they multiply the exponents, right? And then they go, okay, it's 8 to the power of 6. That's wrong. Okay, it's not 8 to the power of 6. It's 2 to the power of 6. You shouldn't be changing the base. Now let's talk about why. How many 2's are there here? In each bracket, there are 2 2's. It's 2 to the power of 2, right? So in that bracket. And then the 3 says, how many of that bracket do you have in total, right? I have 3 of them. So I have 2 to the power of 2 times 2 to the power of 2 times 2 to the power of 2. Now, multiplication is what we call associative. It has a couple different properties, right? It's commutative and it's also associative. What does that mean? It means I can basically take the brackets away. Oops, not the 2 away though. I can take the brackets away and the question doesn't change. It's all multiplication. The order I do it in, who gets multiplied first or not, doesn't matter if it's all multiplication. So all we have here is 1, 2, 3, 4, 5, 6 2's that are multiplying. So we just make it 2 to the 6. So don't change the base. Now here's where things get wacky, right? Think about this one here. We have a negative, a 4, and 3 x's. So if we wrote it out the long way, we have a negative, a 4, and 1, 2, 3 x's in the bracket, right? That's what that means. And we have that entire bracket 2 times. So times -4 times x times x times x. Now when we write it out that way, it's pretty obvious here, right? Negative times negative is a positive. 4 times 4 is 16, right? And then count your x's. 1, 2, 3, 4, 5, 6. So we have x to the 6. So that would be our final answer. I don't need that plus in front. I was just making a point that it's positive. 16 x to the 6, right? Because you have 2 of everything in that bracket. But people kind of they do some wacky stuff with this. This is where writing it out makes a lot of sense. Now, if we don't write it out, again, we can just skip all those steps and just jump to this. But let's think about what's going on here. You have 2 of everything in here. You have 2 negatives. Well, didn't we just say an even amount of negatives is positive? So I'll just write the positive there to make it clear. What's the exponent on the 4 right now? Like, what if this x to the 3 just didn't exist, right? What if it wasn't there? You would have 2 4s, which is 4 squared, right? So you could write it as 4 squared if you wanted. What am I doing? I'm doing the power rule. I'm just multiplying the exponents, right? That's all I'm doing there. So it's 4 squared, which is 16. Then I'm going to the next term and I'm saying, all right, and, well, it's all part of the one term. I have 3x's 2 times. So again, using the exponent law, I just multiply the x's, and it's x to the 6. And then again, we can simplify this and just make it 16 x to the 6. So again, you don't have to show a bunch of steps, but you really gotta think about it, expand it if you need to make sense of the rules. Because those of you that just fly through knowing the basics, but then you start sometimes struggling when we get to more difficult ones. Okay, so final ones here, right? You're gonna add the exponent or multiply the exponents. This is just x to the 6. This one, well, what's 56 times 0? It's 0. And what's anything to the power of 0? It's 1. So I could have just jumped right there. I could have said, it doesn't matter what's in this bracket. Anything could be in there. It's to the power of 0. Anything to the power of 0 is 1. But we're going to make sure you understand that fully in the final example in a second. Now again, this is a 2 to the power of 1. So this 3 is multiplying both of these. You have 1, 2, 3 times. So that gives you 2 to the power of 3. You have 4y's 3 times. So 4 times 3 is 12. And then I can clean up the 2 because 2 to the power of 3 is 2 times 2 times 2, which is 8. So there you go. Now let's be really careful here. We have 4 of everything in this bracket. You have 4 negatives, right? So that's going to give us a positive answer. So I'll just write the positive there for now. Don't need that, of course. You have 1, 2. There's no exponent on it, so there's 1 of it. And you have 4 of them. So that's 2 to the power of 4, right? And let's go through the rest of them. You have 3 of these times 4 and 5 of those times 4. So a to the 12 and b to the 20. Sorry, that looks like a 24 there. That's a little sloppy. All right, there we go. Positive 2 to the 4. So we can clean this up because obviously positive 2 to the 4 is just 16. There's my final simplified answer. Now, if you're doing homework or doing anything and you get a question and you end up with, like, let's just say you do like 2 to the power of like 93. You know what I mean? I don't need you to write out what that is. Okay, if it's easy, like 2 to the 4, let's simplify that. If it's something really ugly or like 5 to like, you know, the 72, we don't need to figure out what that is. Those are gigantic numbers. You don't need to write out all the decimals. Use your common sense to go, this number's too big. 2 to the power of 3, okay, that's 8. We can handle that. 5 to the power of 2 or 3 or something, you know, that's easy. We can handle that, okay? I don't need you to fill your page up with numbers and digits and decimals. All right, so let's move on to the final quick topic here just to wrap it up. Okay, so we already basically proved why anything to the power of 0 is 1, but I just need to make sure that you completely understand its applications, okay? Which isn't very much, just a couple little things to detail. So, like we said before, if you're expanding it, right, think about it this way. 2 times 2 times 2 times 2 divided by 2 times 2 times 2 times 2. Nobody would do this many steps, you know. But what's 2 divided by 2? 1. 2 divided by 2. 1. 2 divided by 2. 1. 1 times 1 times 1 is 1, right? There you go. Now, what do we want to do? We just want to do it the shortcut way, which is subtract these exponents. And you don't even have to show this step. You can just jump to the final answer. 2 to the power of 0. Again, it's not 0. You can't have it be one answer here and then a different answer here. The answer is 1 because you get to the power of 0 when you divide something by itself, like we just saw here. Okay? So they have to be the same. All right, so 10,000 to the power of 0, 1. This very last one, 1. Notice how everything's in the bracket. Everything in the bracket, I don't care what it is, all of that stuff in the bracket is 1. The only place we got to look out for is here. And this goes right back to the very first thing we did in this lesson. Which one of these is positive? Which one of these is negative? Remember what we said? that if there is no bracket around the negative, like this here, there is no bracket, the exponent will only apply to the number. So in this case, the answer is -1. In this case, everything is in the bracket and it is +1. So back to the original thing we were saying at the very start, that if you have a negative in front of any number, anything, okay, and there's no bracket around the negative, your final answer will always be negative, okay? So it doesn't matter what the exponent is, it doesn't matter what the base is, your answer will be negative. However, if you put brackets around it, it's positive.